All right. Okay, so we are gonna solve 815 bus routes. It's a hard question, rather it's a 2D DP question. So let's go to the question ones, and maybe then we can start. In fact, rather, I'm gonna take a screenshot and paste the question here, right? There you go, and a little bit of constraints as well because they're important. Right. Okay, so as you see, the question is 815 bus routes. Now you're given an array representing the bus routes where routes I is a bus route that the ith bus repeats forever. Alright, so for example, if route 0157, this means the 0th bus travel in the sequence 157, 157, forever. You start a bus stop, you start at bus stop source, you are not on any bus initially. So yeah, this is important, right? uh, yeah, so you're not on any bus initially. That's super important. Rather highlight कर देता है, right? And you want to go to the bus target, you can travel between bus stops by buses only. Return the least number of buses you must take. So one more thing is, least number of buses you must take to travel from source to target. Return -1 if not possible. All right. So essentially, you have to take care of the fact that you're not on any bus initially. That's important. Secondly, you have to return the least number of buses. So these are two important things rather. Now coming on to this example, let's go with example rather. So we are given routes. So it is 1 and then 2 and then 7, and then there's another bus. Let's say there's 3, 6 and 7. So just to be clear, this means you're given an array routes representing bus routes where routes I is a bus route that ith bus repeat forever, right? So that means the 0th bus travels in the sequence 157 157 forever. So this could be the first bus, this could be second bus, right? Our source is 1, our target is 6. So let's try to figure out how the output is to. So essentially, you're not in a bus first, so that's the important part, right? Not in a bus right now, right? uh, so you get on a bus, so your source is starting as 1, so you get on the bus which comes on stop 1. There you go. So that is essentially bus 1, right? So now you've boarded this bus, which then goes here, 7, right? Now if you look at it in the second bus, when you board 7, it will actually go to 3 and then 6. Yeah, so if you look at it, you're going from 1 to 7, 7 to 3, and then to 6. Now you have to take the return the least number of buses. So this was your first bus, and then you boarded the second bus. So your output should essentially be 2. Now all the values of routes are unique. Okay, that's something. Now sum of routes of I dot length is less than 10 to the power of 5. I don't really see how this would be more helpful, but alright. Okay, so let's build a hypothesis now. Oh, by the way, I am kind of doing this for the first time as well, so I have no clue either. But yeah, let's go on. Let's see how much can we build. Hmm. Hold on, let me open up my stream. Let's see what's going on. X. Okay, seems good enough. Right. Alright, hypothesis. Well, what I am seeing is it's kind of a graph on its own. So mm, it could be, I mean, the first glance I would have thought of it as a linked list question or something, but obviously, that wouldn't make sense. So this is a graph question rather. It's more about traversing rather than anything else. Um, so my hypothesis is step number one that we have to do is find the bus route that has source. And um, me we could have multiple problems like this. So if there was like 1 to 7, if there was 6. Oh, okay, that's nice. Right. 7 to 1. Okay, one good thing is this will always be in ascending order. I mean, if you look at the pattern, routes of 0 is this. Routes of I of j is either 0 or till 10 to the power 6. Okay, I don't really see. Uh, okay, we can't assume things, but I do believe it might have. If it's in ascending order, we could make it, optimized using binary search, but again, we do not know if that's gonna be the case. So let's assume that it is not gonna be ascending because I don't really see where they mentioned it. So Yeah, no, but but just to make like an examples a bit more towards our side, we're gonna say 248, and there's gonna be uh, probably 1, and then 2, and then 3. So you see, there are, let's say there are 3 routes right now. If the target is, if the source is, let's say, 4 over here, so that's source is 4 and target is 3. So you get on this bus first, and then you do this and then this, and then you have two choice. You can either go here or over here, right? So in all essentiality, we could probably make a graph out of this. Rather, 1 to 7. Now there's 2, so that could be 4, and this could be 8, and this could be 3, right? So now if I start from 4, let's say, I can go to 8, and then I can go to 2, right? Now if the target is 3, we can go where? So if you look at it, it's it's one sort of a graph, but rather I would make it undirectional, because that would make more sense. So there's 4, 8, and 3. Let's say we have 4 where we can just uh, do a bit of jumping, and there you go. So the one problem I see in this is, how can we track the number of buses we hopped? If you're doing this, then how will we do this, right? Like, well, for me, I could like, if we had some sort of a map. So let's say 1, so this, let's say the buses A, B, and C, right? Okay, let me just make it a bit more clear. 248, and clear this out as well. Yeah, so you have 1 as A, about 2 as A, B, and C, 3 as C, 4 as B, probably 7 as A, and 8 as B, right? So we could do this. But right, we are keeping a track, but how will we build the graph? That's the second question. Now we could answer the first question to this. Second question, how can we build this graph? This was especially when the constraint says that you can have 5 around 500 of such routes. Now, is building a whole ass graph for this a good idea? Probably not. because I mean you are gonna have like O of n and then another O of n, O1 of n. So this would go on for probably 520. That's a lot of steps. Like I mean the worst case scenario, the worst case scenario would be 500 into 10 to the power of 5 steps just to build this, just to build this. So this wouldn't make any sense. But since we are doing this is also 500 into 10 to the power 5 steps. That is n into n, or basically m into n rather, considering m is the route length and n is the, so O of mn would be a smarter choice. Okay, right, of mn steps, this 2 is the same. hmm. So if we are building this right, like I mean, aren't we doing this? Okay, yeah, that makes sense. But like, how do we traverse in this, right? So let's say our source was 4, right? Source was 4 over here. So we start with 4 as b, and that also creates one problem. Like, we have to find um other routes with b. You know what, I could do this, and also at the same time what I'm gonna do is create a, and probably put like 1, and then oh, you don't even need to do this either. So like for just refer to routes array, so that would be routes of b. Perfect. So that would give me what? If it was routes of b, that would give me 2 4 8. Amazing. Now that you have 2 4 8, what are you gonna do with it? It's a question. When now we have to traverse this array and figure out a point okay. So before we do all this, we also need to check the target, right? So target is, what is the target? 3. Okay, nice. So target is 3, which is c. hmm let's say if it was d over here, and then this was b comma d, uh, we have to figure out a way when, let's say, we jump from a node, but we should also be able to go to the this thing. So I would rather, like just go one by one. So like let's take 2, right? Now 2 has 3 different options. That is A, B, and C, right? Right. So let's say we go with B, right? Because we were already, okay, since we already were on B, mm, mm, so let's just make it, D and E. Uh, right. Okay, let's not change things. 3 is C. We go with, okay, you know what, 2. Does 2 have something? Fine. We go with A, B, C. B is where we currently are on. So B is out of here. We have A and C. Right. So let's say if we take A. Right. Now route A would have 1 to 7. Right. Now what we will do is again, start with this 1, and probably ask ourselves, hey, this 1 is A. Okay, out of here. 2, nope. 7 is where we see. 7 is A again, so nope. I think there would be a tracking system involved. Mm. So we have to involve the visited system. Let's rethink a strategy. So the bus stop does make sense, by the way, right? Like one of A and so on and so forth. Rather, let's re-hypothesize. Let's collect our thoughts again, right? Here's the thing we know. Mapping to be made. Use BFS. Written answer. So these are three different things that you have to do in a more simpler terms. But in this, we're also adding keep track of visited bus. Right. So let's start with probably creating a function. So routes of 1 to 7. And this is 3, 6, 7. Perfect. Right. Our source is something and our target is source is 1, target is 6. Okay. Alright. So we have a target, we have a source. Now we have to get this thing running, right? So let's create 2 tickets, right? Jira tickets, that's what I would call. First one is to create a function to map. Second ticket would be to create a function to find the shortest path via BFS using starting node and the destination node. So we have 2 functions to create essentially, right? All right, starting with function mapper, like let's call it mapper. Like let's not worry about the arguments and all those things. That could be done by you guys as well. So I'm gonna leave that over here. Now in mapper, let's say we have routes. These are in global, right? Let's assume these are in global, so we'll do accordingly. So now there is routes. To create such a thing, we'll probably create bus map. We'll create a dictionary, right? Now for route in routes, yeah, then for stops in route, Now, right. So we will probably, create some sort of a stop function. Right, so there's routes and routes, so that'll be fun. So, we'll also have to do index. So that would probably involve, yeah. Um, I'll do enumerate here. Enumerate routes and for r of I route index and route, right. We do bus map of route index. No, in fact, you know what? We do for bus map of stop, right? Dot append ri. Yeah. So this will create a bus map. This will create a mapping, right? So what does this return? This will create 1 to 7 into like whatever is required, right? So this will do that. Now we'll go to function short, right? Now we have a map, we have a short, and so on and so forth. Now essentially the question is how to get shortest path when a source and destination is given. All right, it's been almost 40 minutes. We can get it going right now, right? So you're given rather a source and a destination. How are you gonna find the shortest route? So BFS. Let's start with the very important part of BFS, that is queue. So you have queue is equal to deck, right? So that's out of the way. and we have to append something to start it, right? So we have q dot append. Now what do we append here is the question. If we append only source, for example, would that make sense? Let's say we start with only source, and then there's a queue, there's one, and we'll also have to take care of the visiting bus, by the way. So what if there is a two over here, and we have two while traversing something, and that's a different bus. There's A, B, and C. Simpler one thing is we can do is visited bus, like visited, and we can just put A over there, and you can say like if A is there, ignore it and use other things. So we would probably do visited equals this. Now append would be probably source, right? Now it makes sense. Now visited would be dot append. Now if you look up to a thing, right, oh, interesting. What's happening? Okay, so alright, okay, yeah, we are back. I did not realize the stream literally stopped at the for loop. Great. So just to show you guys, we have done this. We have created a map function, enumerate routes, yada yada. It'll give a map. It'll give a map of this, by the way, 1A, 2A, B, and so on and so forth. So let's say we inserted the sources 4. So we'll have something to do with B, right? So I'll have to do bus map of source. Okay, that's nice. Bus map, and that would be src. So this will essentially put up A over here, right? That's what we needed. And yeah, we're starting to get somewhere. So let's start with while loop, right? While queue is not empty, of course. Let's pop some root, right? So we'll keep it as node equals, or rather stop. You know what, we'll keep it at stop. Stop equals q dot pop left. There you go. Right. Now that your stop is q dot pop left, so this is essentially gonna be, what's the source over here? 1. Okay, so just to not confuse you guys, I'll not write this down. Yeah, so right now we had one, we popped it out, and node is equal to 1 right now, and the visited bus is nothing but whatever the one is. So I think one would be, well, 1, visitor is already 1, actually rather 0, right? Yeah, we have the stop, and now we have to figure out what do we do next, right? How do we reach to the destination? So we have one, and just to create a bus map of all the things, by the way. So let's start with 1, will be from 0, right? um, 1 will be 0, 2 will be 0, 7 would be 0 and 1, right? And we have 3 and 6 and 7. Okay, we have 3 as 1, 6 as 1. So this is a bus map, by the way, right? Okay, we have done this. We have visited 0. Now we have stop as 1. Stop is 1, so well, God forbid. Right, we can't just do source. We definitely need the bus as well. You know, something like that, and then we'll have bus. Yeah. So we are gonna do stop in bus, right? The stops in bus rather, because that's the thing. Um, in fact, it'll be routes of bus. Yeah. So this will actually boil down to 0. So there will be 1 to 7 that we're gonna take a look from, right? Now, in fact, current stop. Yeah, and then I can just do stop. First stop and routes of bus. If stop so no, rather, if bus map of stop, that would be on this, is equal to the bus, continue. just, just don't even bother, right? Right. Okay. No, 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 no. Forget that. It was a content list. If bus map was stop, that is this. In fact, uh, if the current bus is in hmm, the window for bus in bus marker stop, and that will become, if current stop and current bus, this will be current bus as well. This will be current stop. Nope. Okay, no, that'll be just be stop. Yeah. If bus is equal to current bus, continue, right? So 0 will go, 0 will go, 0 will go, and then 1. It'll reach 1 over here, right? If it's not the same bus, we can put it into queue. Like, hey, queue dot append the one that is the bus, 2 that is the stop, right? So we can what do we append? Stop on the bus, right? Stop comma bus, right? Oh, in fact, one more thing. If bus in rather visited would make more sense. So you have visited as 0 already, right? If it's 1, then you don't have to visit it again. There's no point of it, right? So we have to move on. Now you queued up in as 7 and 1. So queue dot append is 7 and 1. Interestingly, well, if you look at it, our destination 6, we loop through it and then realize, oh shit, we are missing out on it. So we have one more condition to add over here. If no, rather not over here, but over here. If stop equals destination, return length of visited. There you go. So I'll go over here, I'll pop the 7-1, and then current stop, current bus, then we'll start doing this entire thing again. Like, hey, do me a favor and start with 3, 6, 7. Then you go and like, hey, 3 is the stop. Can I do 1? Nope. Move on. Then can I do 6? Well, stop equals destination return, length of visit 2. That should be your answer. So uh, seems like we are very close to it, right? um, Also, if we are adding, right, but we have not added the visitor into the visitor part. So I think once you append it, we can also visit.append um, bus. There you go. And yeah, that's about it. So this should essentially solve the problem that we are worried about. mm, 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 mm. So if nothing is found in the end, we'll also return -1. And yeah, okay. Also over here we have to do if source equals destination returns you. There you go. I think I think this is enough for now. Also, right, a stop not in visited stop should make sense. Also put up something over here. Let's say one has been already visited and you go back to one by any chance. Why do you have to waste time? You already know it's not there, right? That's not a should anymore. So we'll also put visited stop. Um, yeah, we'll put visited stop over here. Dot append would be stop, right? Then go ahead. I think this should be enough for now. Right. So yeah, this is about it. I think we are done over. We have successfully written a function. We have successfully made a mapping, and in all technicalities, this should work because you start at 7, 1, and then you do the same. You start with hey, uh, well, you have 7 appended and visited stop, right? So now what this will do is go back to first stop and routes. Current bus, that would be, well, 1, right? So 1 is the thing. Is 7 the destination? No. For bus and bus stop, bus map stop. So right now our stops are from 0 and no, our stops are from bus, also from bus. Okay. Interesting. Okay, so that would bang up 1. That would be 367, right? 367, and from there we have like, okay, we start with a stop that is 3. So if stop is not in visited stop, well, it's not in it. So we go ahead and like, hey, bus of map of stop. So that's 3 is 1. Now bus and visit it and just continue like if um yeah, one is already visited, then just continue. um and let's say we go back and then we add the stop over here. So we have 3. Okay, then we have in the the this thing, like whatever we visited, we have added 3 over here. And we go to 6, and then you're like, hey, first stop in 6, destination, yep, return, length of visit. So the visited was, well, already 1 and 2, so the length will be 2, and that should be done. So yeah, we are done. I think even the dry run makes sense. So we are gonna code it out in the next stream. See you guys. Thank you. Bye bye.